Thanks very much. Let me get this going. All right. So I'm going to talk about supercharging the connected home with a software-defined edge. And just before I get into that, wanted to introduce Benu Networks, since some of you may not be familiar with us. We were established in 2010. We have global offices and are headquartered in Boston, which is where I'm located. And we are an industry leader in software-defined edge solutions, focusing on the carrier edge, and very engineering-led. We put 80% of our investment, 80% of our employees are in the engineering organization. So we really take innovation very seriously. Like I mentioned, we focus on the software-defined edge, and we have a broad product portfolio, but the space, the type of product that we're going to be talking about in this presentation is the BNG, which stands for the Broadband Network Gateway, which is a node that basically aggregates subscribers coming in from DSL and PON connections and does the authentication and is considered the service edge by the carrier for those connections. We also have other products that are complementary, like our WAG, which is the Wi-Fi access gateway for hotspot and mobile offload services. We've also announced a 5G access gateway function, which I'll talk about what that node is as it's defined in the standards later in the presentation. We also have a SASE gateway, which is for basically network-based security services and provides a way to secure individual users and devices very effectively. And then we also have a solution in the UCB space. And all of that is managed with our Benu Cloud services and solutions. So, and just in terms of our breadth of deployment, we have been deployed by a lot of carriers worldwide. We have a lot of large partners that are making massive investments into the telecom and networking space, and so we're excited to be partnered with them. We are deployed at quite high scale, so we have about 7 petabytes a day of traffic going through our network, which turns out to be more traffic than all the mobile operators in North America combined. It turned out to be, as I looked at, like, is that a lot? It's actually quite a bit of traffic. We have over 24 million connected homes and businesses connecting through our software. So we're excited to be helping our carriers, really customers, carrier customers move to the next level in terms of enabling services with this connectivity that they're providing to all these homes and businesses. And what I wanted to talk about today is some of the exciting things occurring in the home network and how that impacts the carrier infrastructure. So the first one is the 5G rollouts, and there's an opportunity now because Broadband Forum has collaborated with 3GPP. They're really working towards what's called wireline wireless convergence, enabling 5G level services and capabilities to be offered to fixed networks and home networks. And so that's an exciting opportunity. There's also this massive shift to move security from traditional appliances to the network, and that is delivered via secure access service edge. And this is basically a capability that provides security for individual users and devices from the network. And as mentioned earlier, security is becoming of prime importance to consumers, whether it be for their individual laptops or phones, but also for IoT devices, which are exploding inside the home. And also furthermore for remote workers who are, now, it was very common for, remote workers to be, working from home 100% of the time. But even now we see a lot of companies announcing that they will be doing hybrid work weeks and things like that. So all these things, the IoT, the cloud reliance, the gaming, and of course, virtual and augmented reality coming down the pipe are having a tremendous strain on carrier infrastructure and home networks and what the home CPE device needs to provide. And what the carriers need is an ability to have an effective way to roll out advanced home services. And this means the ability to have unlimited feature upgradability for these advanced services, unlimited compute capacity. What do I mean by that? I mean, if you think about the cloud providers, that's effectively what they have. And that is why they have been able to move so quickly, because they're not constantly sort of swapping out hardware platforms and waiting for hardware life cycles. They can move at the pace of software and internet innovation. The other thing is, there are times where there may, traffic is not smooth. And so there's peak traffic spikes for any home network. And the ability to offer an advanced service, not just at 100 megabits per second, but maybe at a gigabit per second service, requires a very beefy CPU. If you're doing anything it requires some advanced computing. And so that's very difficult to justify putting such a large CPU device with such a large compute power into every single home. However, you can use that kind of compute power in the network. And so that's another thing that is something that is possible, using these network-based solutions. The other thing is future-proofing. So you don't want to have to rely on hardware solutions. You also want to have network-wide compatibility. So a lot of times when we talk to our carrier customers, they're lamenting about, I've got these old CPE that are 5-10 years old. They can't support all the new services we want to roll out. We can't upgrade people and upsell them to these new services. We have to swap out the hardware, which ultimately turns into a customer care call. So what if you could roll out services to 100% of your base and not have to upgrade the CPE? That would be a really ideal situation, right? And that gives you then the agility to move quickly, because you're not relying on that upgrade cycle. So there's kind of, I'm alluding to the fact that there's multiple ways to deliver capabilities into a home network. And we have, because we sit at the carrier edge, we have an approach that can supplement what's being done inside the home. Some capabilities, like getting the latest Wi-Fi technology, latest Wi-Fi standard into the CPE, or supporting better mesh capabilities, those things inherently have to be done via the CPE upgrade. But there are many, I mean, most of the services that can be offered are really software services. And so when you think about where you want to implement those, one area that you should consider is a network-based solution, which is often overlooked. But there's tremendous advantages. You get all of these capabilities, that feature upgradability, the compute capacity, the ability to handle the peak traffic spikes. It's a more future-proof architecture. And you have network-wide compatibility. Basically, you don't rely on the CPE for these advanced services. So the old CPE that's 10 years old, the brand new one, can have the same service experience, and the users would not really know the difference. And then lastly, of course, is the agility. I mean, if you look at the cloud computing providers, look how fast they are innovating, adding new capabilities. And that is really because they're doing things, in a network-based sort of solution. They're not relying on a massive number of hardware platforms that are deployed, all around homes and businesses. And so they're not tied down to that kind of infrastructure. So this really gives, the advantage to anyone that's using network-based solutions to be more agile. And of course, it's simpler to manage because you don't have tons and tons of instances of the individual services being rolled out. So how does this look from a network standpoint? So let's take an example home. And we'll say there's someone that lives there named Mike. And I think that Mike's got a private network there for his home network, but he also works remotely some of the time. So his carrier has put a second SSID on the Wi-Fi CPE called Acme Corporation. They've done that on behalf of the enterprise. And so they're selling basically a remote workforce solution. And this is, of course, a huge opportunity for carriers to expand their enterprise business. And the connection there goes, all of the traffic is going through the BNG. That's basically the way the traffic is routed. It's the first point of IP services. And so the BNG, the Broadband Network Gateway, is a very natural point to have services executed because it knows it has these individual subscriber connections. It knows which traffic is from which home or business. And from there, you could do things like SD-WAN. So for the remote worker connection, it could be routed appropriately, the traffic to private cloud, public cloud, or tunnel via IPsec into the headquarters. And you can also run a variety of edge compute services right there on the BNG. Security services, things related to augmented reality, virtual reality, gaming, IoT. One of the things in the survey shown earlier by Omdia that Michael showed was that IoT security was growing in consumer importance very heavily. And here's a place where it's a very natural place. It's a very natural place to put that security and basically lock down that IoT device that is only talking to its cloud controller, and it is not using an inappropriate amount of bandwidth or things like that. Another aspect of this architecture is you can run some of the CPE functions like DHCP, address assignment, the NAT, the DNS, they can be moved to the BNG. And by doing this, you essentially have virtualized the home router, and it enables per device policies and services, because now the BNG not only sees the individual homes and businesses, but sees all the devices inside it. So this is what allows you to then potentially create different slices for teleworking devices versus gaming devices versus IoT devices, and have differentiated services, QoS, security, etc. This also makes the fixed network look a lot more like a mobile network. The mobile network, communicates with the individual device, the individual mobile device. And normally in a fixed network, the fixed network is really just seeing all the traffic coming from a CPE. However, with this type of architecture, you now have the fixed network understanding what are the individual devices and able to provide policies for those. So some of the advantages of this architecture, for one, you could use any Wi-Fi access point or CPE. Really doesn't have to have any special capabilities at all. You don't require any VPN clients on the individual laptops or phones to provide some of these enhanced capabilities. It provides support for all devices, including any kind of IoT or gaming device. There's no limitations there. You are setting your network up for low latency compute at the network edge, even if you're not using it right away. Perhaps you're just using some security services that don't necessarily need low latency. You now have a service instance there that can be used in the future for any kind of low latency capabilities, and being able to roll that out quickly is obviously an advantage here. And the per device slicing for the QoS and security, the optimized application routing and SD-WAN, and then you could actually offer enterprise grade level security to some of your consumers if they have the concern that they want to have more advanced security capabilities, particularly as the number of cyber attacks have increased. And of course, for any kind of remote work solution, the enterprise is going to want this for sure. So why now? Why is this possible now? Well, the stars have aligned, and there's three stars that I'm talking about. For one, the Broadband Forum has defined TR 459, which is control and user plane separation. They've taken a page out of the 3GPP book, which is the same, has a similar architecture, similar protocol, and allows you to keep the control plane centralized and all the subscriber management, which simplifies the overall management of the network. But you can move the user plane out to the edge, and that's where now you can run all these services and do so very economically. The other thing that has emerged is the cloud native BNG. It's lower cost than your traditional monolithic solution, particularly in a distributed architecture like this. It enables microservices and automation. And with that, you can also then very economically virtualize thousands of home gateways on an individual BNG, and thereby enable all those per device slicing capabilities. And finally, the last star is the hyperscaler-based applications that are moving to the edge. There's massive investment here. It seems like every couple weeks, I see a major tier 1 carrier expanding their partnership with one of these major hyperscalers. And the big push here is to, with AWS Wavelength and Outpost, or Azure Edge, Google Anthos, is to push out their compute closer to the edge for new applications. I think the carriers that take advantage of these three stars that are aligned really set themselves up for significant differentiation, not just slightly better features, but significant differentiation in terms of their capabilities and their agility. So what's next? What is coming is the definition of 5G wireless wireline convergence, which, like I alluded to before, enables fixed network subscribers and devices to be managed via the 5G core. And this then enables a consistent user experience across both fixed and mobile. And a perfect example, at least for me, would be if I could have consistent parental controls where I set it up once and all of the devices, the numerous laptops, phones, tablets, are all getting the parental control settings that I got, regardless of whether they're connecting on the Wi-Fi network or the mobile network. And doing that sort of once versus configuring like 12 different devices would be fantastic. The key network element that enables this generation of convergence is the 5G access gateway function, and optionally you can have a 5G user plane function integrated with it. It's essentially an evolution of your broadband network gateway, which is also defined by the Broadband Forum. So both of these defined by the Broadband Forum. And as you can see, you can have the user planes separated from the control plane, leveraging that CUPS infrastructure or architecture that I've mentioned on the previous slide. And it has interfaces into the 5G core for the policy and authentication. So it's an exciting time, and I want to thank you for joining us for this session. And I think at this point, we've got a little bit of time for some questions.
All right, thank you, Michael, and thank you everyone from session 1 here. We do have a few questions coming in. The first one actually usually last in, first out here, right? So Michael, are there any 5G AGFs on the market right now?
So it's a new platform or a new network element that's been defined in standards. So I don't think there's anything commercially deployed yet, but Benu did announce our availability of 5G access gateway function. And I believe there may be some other vendors working on that solution because there is a lot of momentum, I think, within the industry towards this convergence.
All right. Just a quick question for Zvi and Magnus. I was wondering what you guys think between using QED to optimize and then using in optimizing Wi-Fi specifically, without going too much into the regional differences. What do you think are the most important statistical information that is needed to know that we need to know from the Wi-Fi networks in order to do a lot of that optimization?
Well, we've actually done quite a bit of research on this and done a lot of machine learning and tried to figure out which features are the most important. And what we're seeing is radio environment data. So first, data rate, which is derived from the signal strength and the capabilities, is super important. The two other ones are how much time is being used by competing access point and how much time is being used within your own access point, within your own network. If you got those three, you get a really long way. That's for live data, right? So when you're looking at things, let's say a bigger picture, it's more number of competing access points and signal strength.
Well, I have to, to agree with Magnus here, because it is correct, and you can add a bunch of a variety of different parameters that you are looking for, like also if you have an SNR, that would also be efficient to monitor on the radio side. We see also, not just the neighboring Wi-Fi and the number of neighboring Wi-Fi networks that we see and their channels and the range that they are using, but also the number of hosts that you have within your own network. This should be also a parameter, because if you have too many devices connected on your Wi-Fi and someone is right now in an online gaming session, so he will be consuming a lot of your bandwidth. So it depends on what information you are trying to evaluate and which score and how to build this score for your own internal customer. So definitely I would take and expand this with some, this could be also with the transmission rate that you have on your uplink as well, to verify if you are consuming everything. This would be giving some more information between what is related to the root cause, if it is on the Wi-Fi side or maybe on the uplink layer as well.
Okay, I guess, so another question for anyone, probably Michael can probably talk a little bit about this too. Are there any examples of operators that are actually realizing additional revenue from either Wi-Fi services or additional QoE or some of these virtualized services that Michael is talking about to kind of reducing churn and OpEx?
Yeah, sure. So I'll go first, Jason, and other people can join in. The quick answer is yes, but at the moment, I would say the increase in revenue and ARPU, and if people are interested, I can share specific examples if they reach out. But it's mainly at the moment focused around increasing the attractiveness of the top broadband services. So, every service provider has a broadband tier, and it's all about trying to get more or a greater percentage of customers taking that top tier, and they're doing that by loading up not just with broadband speed like it used to be, but with better Wi-Fi connectivity and other types of applications such as IT, cybersecurity kind of lumped in and things like that. And that is proving successful because, as I say in my slides, you're seeing an increase in the number of percentage of customers that are taking those higher tiers. So it is working. And what I would expect to see in the future is then applications that are then specifically, charged for as an additional premium. But at the moment, the focus is on about that service bundle, if you like. Yeah.
Right.
Yeah, I think you're right, Michael. It's that's the number one thing. There are operators who are charging additionally for both high-end Wi-Fi access point, also mesh solutions. And now we're seeing the first solutions have been launched this year, which have specific gaming solutions. I know there's a US company, US service provider that started offering that. There is coming very soon someone who are doing specific work from home packages as well. So it's beginning.
Good.
Yeah, I would second the work from home is starting to grow quite a bit. We have probably deployments going across about 20 countries where carriers are taking advantage of the fact that the enterprise network is now extending into the home.
Right.
And the homes are completely exposed. They just don't have the level of security or management that an enterprise would want to have. And the carriers are in a very good position to deliver to that on that.
Right. I'd say, so as we move on, I think my favorite slide is from Zri, the one that reminds everyone that the customer thinks that Wi-Fi is the internet.
Yeah, we see this a lot.
At the end of the day,
Yeah.
hear why it's not working, or, you know, what was the universal example we use, Rhonda? The your teenage daughter doesn't care why it's not working. All right.